Hello and welcome to Controllers Tech. I have covered a lot of videos in the W25Q series explaining different topics, which include the regular SPI flash, and also the quad SPI mode. I have also covered the video explaining how to create an external loader for the custom board you are using. Even after explaining it in so much detail, some of you still have issues running it on the Cortex-M7 based boards. So today this video will explain how to do everything related to W25Q external flash memory on a H7 series microcontroller. We will see how to set up the quad SPI peripheral, how to add the libraries, how to test if everything is working, how to create an external loader, and finally how to use the loader. I am going to use the STM32 H750 custom development board from DevBox. These boards containing the H750 and H743 chipsets will soon be available on Controllers Tech Store, so the Indian audience can purchase it from there. Today I am using this H750 based development board. Both these boards have W25Q 64 external flash memory connected via the quad SPI mode. Here is the zoomed in picture of the board, and here you can see the W25Q 64 chip soldered on the board. I am going to use my own tutorial to set up the W25Q flash in the quad SPI mode. Here is the schematic for the development board I am using. Here you can see the W25Q flash memory is connected via the quad SPI mode. We will set up our quad SPI peripheral according to this. Alright, let's start the Cube IDE, and create a new project. I have the STM32 H750 VBT6 MCU. Give some name to the project and click Finish. Let's start with the clock setup first. I am choosing the external crystal for the clock. The board has 25 MHz crystal on it, so make sure the input frequency is set to 25. Here you can see in the image, the 25 MHz crystal is present on the board. We will run the system at 400 MHz frequency. Alright, the clock is configured now. Go to Quad SPI, and enable Bank 1 with quad lines. Now first of all we will set up the pins as per the connection shown in the schematic. You can search for the pin name, and then enable the respective quad SPI function for that pin. Alright, all the pins have been configured as per the schematic, so now we will configure the parameters. I am going to configure it as per the tutorial. The quad SPI clock is running at 200 MHz, so let's set the prescaler to 1, which will bring down the clock to 100 MHz. The FIFO threshold is set to 4, and the sample shifting to half cycle. Next is the flash size. Here is the formula to calculate the flash size. The value here in this tutorial is 21, for the 32 megabits flash memory. So for the 64 megabits memory, the size will be 1 higher, that is, 22. That is all we need to configure the parameters. If you check the pin settings, all the pins are configured with low output speed. We actually need these pins to have the maximum output speed. So select all the pins, then scroll down, and set the output speed to very high. Now since we are using the Cortex-M7 core, we need to configure the memory protection unit also. Enable the MPU in the default mode. Now enable the first MPU region. Set the base region to 90 million hex. We have 64 megabits memory, so the size is 8 megabytes. There is no sub-region. The text field level should be 0. Set the permission to all access permitted. Instruction access should be disabled, shareability should be disabled, and enable the bufferable and cacheable permissions. Make sure to enable the iCache and dcache. Now let's go to the project manager, code generator, and check this box to generate the separate library files. That is all we need to configure. Click Save to generate the project. Now we need to modify the QSPI files. I will use the code from my previous tutorial again. Let's download the project from this tutorial. We need to copy the code from QSPI files. Let's copy the code from user code 0 part to the same part in our project. Now copy the code from the user code 1 to the same part. Next we need to copy the code from the QSPI header file to our project. The only data we need to modify here is this, the memory size. The memory size is 64 megabits, so set the equivalent hexadecimal value. Our QSPI driver is ready, so we need to test it. I will use the QSPI testing code from the SD's GitHub page. Here is the SD's library for the external loader for the QSPI flash memories. Switch to the contribution branch. Here you can see the QSPI testing folder. Open the mun test file. Now let's copy the content from this file to our main file. Alright, let's build the project now. We don't have any errors, so let's debug it. We will set a breakpoint to our while loop. If this breakpoint is hit, that means the test is successful. Let's run the debugger now. Alright, we have hit the breakpoint, which means the QSPI testing is successful. Actually, in this we first initialize the memory, and then erase the first 100 sectors. Then we write data to these sectors. Then we enable the memory mapped mode, and compare the data stored in these 100 sectors to the data we wrote. If there is any mismatch, the control will enter an infinite loop. Since the memory mapped mode is enabled, the external memory is mapped as an internal memory, and hence we can even view the external memory in the Memory Viewer tab. Here you can see the data present in the external flash memory. Now that the memory test is successful, we will create and test the external loader. We will use the loader files provided in the SD's GitHub page, so let's download this entire code first. We need the loader files, so open the folder. We are using the H7 based device, so open the respective folder. Now copy these files inside the project folder. Copy the C files inside the source directory, and H files inside the include directory. Also copy the linker script in the main project folder. Let's open the device info source file. Here we can set the name for the loader. I am setting it to H750, W25Q 64, dev box. The start address is set to QSPI address, 90 million hex. The memory size is fetched from the QSPI header file, which we have already configured. Alright, now open the linker file. Here check the size of RAM D1, and set it according to your MCU. Comment out his code which we wrote earlier to test the memory. Now we need to set the linker file as the default linker file for this project. Open the project properties, go to CC++ build, setting, GCC linker, general. Here the flash script is set as the default linker file, so change it to the linker script file we copied just now. Make sure to uncheck the Discard Unused section box. Now build the project to generate the loader. Our build is successful, and you can see in the memory details, now we only have RAM D1. Let's delete this debug folder once, and rebuild the project again. Alright, the debug folder has been generated again, and our loader is inside this folder itself. This ELF file is what we need. Let's open this folder in the System Explorer, and copy this ELF file inside the main project folder. Now rename this file and give it the extension stldr. Our external loader is ready now, so we will quickly test it. We should create a new project to test it, but I don't want to waste time on creating another project, so I will test it on this project itself. Let's exclude the source files we just copied from the project. We don't need these files anymore, as our loader is already created. Now delete the debug folder, and we also need to set the linker back to the Flash script. Also make sure to check the box for Discard Unused sections. Now let's build the project once to see if everything is fine. We got the memories in the Memory Regions window. Now initialize the QSPI driver, and enable the memory mapped mode. Open the Flash script, and define a new region, QSPI. The start address will be 90 million hex, and the size is 8 megabytes. At the end of this script file, we will define a new section, where we will relocate the data from internal Flash. This section will point to the QSPI region we just defined. Let's build the project once. Here in the memory region you can see the QSPI region has also been added. Now let's define the data that we want to copy to the QSPI memory. Also define another buffer to store the data, which we will read from the memory. Right now this buffer is defined in the Flash memory. To relocate it to the external Flash, we need to give it a section attribute, which should point to the section we defined in the Flash script. Now inside the main function, after the memory has been mapped as the internal memory, we can use the memcopy function to copy the data from external memory to the buffer we defined. Let's build the project now. Here you can see the QSPI occupancy is 27 bytes. These 27 bytes are the data bytes we relocated to QSPI memory region. Alright, that is all we need here, let's test it now. Since we are writing the data to the external Flash memory, we need the loader to do so. Open the debug configuration, go to the debugger tab, scroll down to external loaders, click add to add the loader. Since I have the loader inside this project itself, I am using the workspace to locate it. Alright, click apply to save the configuration, and debug the project. Let's open the memory viewer to check the data in the QSPI memory. I am setting a breakpoint here. We have hit the breakpoint, and the memory is still not accessible. Let's step over this statement. The memory has been mapped as internal memory, and now we can access it in the memory viewer. You can see that it contains the same data that we relocated to it. The read buffer is empty right now. Let's step over this statement. The read buffer now contains the same data that we have in the external memory. So everything is working fine. Instead of copying the data from the buffer we defined, we can also copy the data from the external Flash memory location. Let's quickly test if we can copy the data successfully here. The read buffer is empty right now, And when we step over the statement, we get the data stored in the QSPI memory. So we were able to successfully test the external loader we created. We can now use this loader in our application to copy larger data to the external flash memory. We will use it in the next video to load the entire LVGL from the external memory, basically the XIP, execute in place. This is it for the video. We were able to test the Quad SPI flash memory, created an external loader for our custom board, and successfully tested the loader. I hope you understood everything explained in the video. You can download the project from the link in the description. Leave comments in case of any doubt. Keep watching, and have a nice day ahead.